Dan D'Almeida from Scitara, who will be talking about lab interoperability with DLX using the ASM JSON format. Dan is the head of product management for Scitara and a scientist and product executive who has decades of experience connecting technology and business focused solutions on customer-focused solutions in the laboratory industry.
All right. So great lead up by Matthias. We're going to talk about lab interoperability with Scitara's DLX and using the Allotrope ASM JSON format. And I thought it was interesting that he also mentioned a common language. You know, in 1941, Albert Einstein gave an address that discussed the common language of science. You know, first he talked about the evolution of language itself, how it started with simple gestures to signs to words, and then those words needed more meaning and context that delivered into sentences and grew a little bit longer from there. Then later described how the language of science required a little bit more precision in its concepts around data, which is really interesting. And you can see that scientists have really leveraged this common language of science across the world. With that, they've created these vaccines, medical devices, other life-saving products. You know, it's amazing how quickly technology has evolved in the scientific industry. They also work in many different industries, right? We think of pharma a lot, but there's food and flavor, environmental scientists across the world. And all of them are somewhat using technology, but the technology that's been introduced to help automate their data collection or simplify it doesn't really talk to one another the same way the scientists do. And when it does, it doesn't have a common language to interpret that data. So with the increasing number of software instruments and devices used in the lab, that amount of data has grown exponentially, meaning there's more resources that are required to collate and interpret it manually, right? All of these silos and fragmented infrastructures make the workflows really challenging. And so the current lab infrastructure is really application centric. So when you think of, you know, our applications and our devices or data lakes or whatever else, they're really built on these point-to-point solutions. And so when we go in and collect data from an instrument, it may come from that instrument into your LIMS environment, or it may go from your streaming data systems into your ELNs or LESs. And as we look at all of those, now you have all of these very bespoke point-to-point solutions that make it really difficult to manage and maintain these systems. And so, again, that architecture, right, requires all these complex integrations. The data generated tends to be stored in multiple places. There's no common source of truth. It gets really hard to translate between systems. Those data transformations require custom parsers or solutions, really, and again, that point-to-point solution. So if we shift our mindset a little bit more and think less about point-to-point and that application-centric model, we go towards more of a data mobility model. It sort of changes the game a little bit. And what that means is, instead of making it really about the applications, make it about the data, right? This new paradigm makes data the key asset, which is where it should be. Data is self-describing, doesn't rely on the application, right? That means it's open, it's non-proprietary formats that can really be shared across the workspace or the organization. The access is there, it's not managed by the application and locked down. And again, you know, the applications can still have access to the data, you know, as it says here, perform that magic and express the results, process back, go into the next layer. And so if we look at that same diagram in a different way and more of this peer-to-peer model, you can see that now the systems become really opened up. And that flow of information is really easily exchanged. And this could be in a variety of different ways. You know, if you have, you know, to leverage the keynote today, you know, if you look at more of an OPC standard when you're connecting it and you have a plug and play OPC connectivity there, that is really shared across those common applications or common devices in the system, it really opens it up. But what you need is actually an infrastructure that supports this. And so that need is really around universal connectivity, right? Right now, we're really disconnected. Again, bespoke custom solutions. We have these development shops that build integrations from point to point, or we have vendors that have very specific point-to-point solutions. But with a universal connectivity solution, it really opens up the ability to, the opposite of these statements here, to make the data more easily transferred, to make it multi-directional, if you will, instead of having these bespoke systems have more of a plug and play open system instead of a closed system. And the reason is, it's an estimate that about 50% of lab time is spent on data preparation. So with all of these tools and automations that we have in the world, it's really complicated, the manual processes to keep up and interpret that data. So some of those points being, if we have poor connectivity, that means those repetitive workflows can't be automated, right? It's poor efficiency, if you will. And then we can't leverage tools like AI and ML to really curate or properly format it or do analytics and insights on it. The lab assets are not managed holistically. Compliance, it's hard. It becomes really hard to do compliance and increase your regulatory risks. Total cost of ownership goes up, which is always the bottom line that people look at. Implementation times, if everything's a custom solution, then every integration becomes its own project. And that really delays getting to where we need to with deploying the technologies to help automate these manual tasks in the lab. And then, again, if everything's in a silo and everything's in different systems and it's really hard to access that data, then the scientists don't have access to that knowledge, and that's really where we need them to be. And again, they're the greatest asset in the company. We should have those scientists, the creative people, really innovating and spending less time on the manual data curation. So other industries have really taken on technology, but scientific labs have unique requirements, right? We've talked a little bit about compliance, regulated markets, and then being able to really provide that data to the decision makers along the way. So what we need not only is connectivity the first challenge, so we've talked about how connecting the system, but now that if we have an infrastructure that connects all of the systems, and it's a really plug and play technology, then the second step really is around data normalization. Because you might have all of these different instruments in the lab putting out different results, but you do buy many of, it's not all individual instruments. You buy many of the same type of instruments to perform the same tests because you want to scale up your processes or your manufacturing. But what you'll realize is if you purchase the same instrument from vendor to vendor, that output might look very different. And let's be honest, we don't always purchase the same instrument from the same vendor. But even if you did, from version to version, that output data might be very different. And so let's take an example of that. If we take an example of an HPLC system, this is just a subset of results that might be collected from an HPLC. And we have HPLC 1 on the left and 2 on the right, and we look at the output results. So again, if these are from different vendors or different versions of the software, you might actually have the output look slightly different. So on the left, you have 3 different labels, peak, RT, and concentration abbreviated. And on the right, you have name, time, and peak concentration abbreviated. And to a scientist, that's the same. We understand, we interpret that very easily. But to a machine or a computer or software, those are 2 very different data results. And so that requires someone to manually go in and interpret that data and map it back and forth. And so where we really want to end up is to a level where we look at something like peak or name and give it a common terminology like peak name, or we look at RT and time and give it a common terminology of retention time. And again, look at concentration, peak concentration, and define it as concentration. And as you scale up through your environments, you might have more varieties of this. And the goal is really to bring these into this common definition, right? Because, while the results are interesting, a result with context and definition is a lot more valuable than just a label and a value at the end of it. So where Allotrope can really help out is with the Allotrope simple model. It's a JSON-based standard, right, for collecting and structuring instrument data. So going back to what we were just looking at previously, you take all of these disparate but similar output results, and you give them definition. It's designed to be easy to read, write, and transmit across systems, and it leverages that formal vocabulary that's already been defined in the Allotrope Foundation ontology, right? So that ensures that consistency, and this will help to find that common language for our output results. Now, if we go back to the first challenge, which was really around connectivity and the infrastructure for data mobility, that's where the transformative power of a scientific integration platform can really help out. And Scitara's DLX is actually at the heart of the Scitara SIP, if you will. It really takes all of that data, and going back to that diagram, allows to connect multiple network endpoints, right, through connector technologies. And those connectors can be built either very specifically for a vendor or leveraging an industry standard, OPC, web services, serial connectivity, and allowing us to very easily have a plug-and-play ecosystem, right, that allows these integrations and orchestrations to happen across the applications and services. It's very flexible, very easy to use, and really opens up all of the data sets from both old and new instruments and applications. And so if we take a step a little bit higher and look at an SIP, what that does is you have your on-prem applications and devices and build all that connectivity through it. You have your informatics systems and connect all of those informatics systems and devices on-prem through a peer-to-peer network. And then with the abilities to use a data orchestration layer, we can really open up the lab's existing application ecosystem. So that transfer of information becomes very easily scalable across the environment. So again, making all of your informatics systems peer-to-peer, it supports putting into data lakes, putting into archives, doing instrument management and analytics on the data you have existing today. So with the combination of SIP and DLX and the Allotrope ASM, then you can see how data in flight as we're going through this infrastructure that provides data mobility can really be transformed, normalized, connected, and standardized across the environment to provide it with this common language. So it's a flexible flow of exchange of data. The ASM functions as an interoperable data layer. DLX can perform data transformations in flight. We can provide scalability and modularity with the library and ASM with the plugins connectors that we have today. So this really opens up the common language of automated science. As we talked at the beginning, where scientists can interpret these data and have created all of these amazing discoveries with the common language of science. Now we can leverage ASM and DLX to really provide an automated language. So our instrumentation and all the technology in the lab really allows it to have the same communication layer that scientists have today. So with that, we want to provide a special thanks to Allotrope for providing the support and critical review with this. And I'd like to open it up to any questions that we might have about DLX or ASM.
Great, thank you, Dan.